Dear colleagues, we have been working with a metal structure factory to conduct studies and have developed a software model for automated projects analysis. This model helps to calculate the amount of work needed, the estimate time for completion, and the overall project cost. Before implementation, this model, the shop administration relied on an outdated method of measuring aggregated indicators beside solely on the mass geometric parameters of the products. Our software helps manufacturers conduct functional and cost analysis of the project even during the initial stages of agreeing on order fulfillment terms and making critical decisions. We want to thank the reviewers for identifying certain points that have been not fully covered in the manuscript. To address this, we have decided to include them in our reports to present our work as comprehensively as possible to the participant of ITTAP 2024. To successfully operate the software model, we use 3D modeling tools. This method enables us to gather specific data on the geometrical properties of the structural profiles. The software modeler does not require creation 3D models or cloud service for storage. We employ 3D modeling tools to develop and validate mathematical models for the software model. Each profile is associated with four mathematical expressions, allowing for calculations the perimeter and area for any selected cross-section. The data we collected from 3D modeling was represented by an approximate function. Typically, this function were polynomials 2 or 3 power. We assessed the accuracy of the mathematical model using the coefficient of determination. The closer r power 2 is to 1, the better the approximating function describes the set of data points. Sometimes we used a general nonlinear regression algorithm. We discussed these models and their calculation algorithm in detail during the ITTAP 2023 conference last year. The system has an extensive network of connection between individual software components. We have developed about 20 different schemes for transferring information among the structure's components. The most rational option was to create summary forms for the report as a collection of separate modules. Each module performed its small calculation or analysis. We use a special modeler to determine the necessary parameters for the structural profile, taking into account the method of mechanical processing and geometrical characteristics. Other models are responsible for the respective data areas. Breaking down the software model into separate functional blocks allowed us to use different algorithms to determine the characteristic of various structural profiles and processing type. Our result is suitable for enterprises of any organization complexity and can be used on stationary professional computers and laptops. Thank you for your attention.